This is the lesson for Handout 2A. So let's take a look at our first problem here. Here it says we're supposed to determine whether the given point lies on the line, defined by the equation below. So here's the equation, and here's the point. And so all you're going to end up doing is taking the x component of this ordered pair and putting it in for x. And then you do the same with the y component of the ordered pair. You put that in for y. And so what we'll end up doing is rewriting our equation. But in place of the x, again, we're putting that 3, because that's what the point is. That's what the x value of that point is. And then in place of the y, you put the 2. And then you set this equal to 12. And so we go ahead and do some work here. 2 times 3 makes 6. And over here, 3 times 2 makes 6. And those two numbers do add to make 12. And so when the two numbers do equal, we say, yes, that point is on the line. Just a few more to practice like that. Here we have negative 2y, so we're going to rewrite the negative 2, but in place of y, we're going to put the y value of that ordered pair that we're determining whether it is on the line or not. And then bring down the plus 1/3 times by x. Well, x here is 9, so we're going to put that 9 in place of this x here. But since I'm dealing with a fraction of 1/3, I'm going to write 9 as a fraction as well, 9 over 1. And so hopefully we'll see some cross-canceling, so to make the problem a little bit easier on ourselves. Well, we go ahead and multiply these two numbers. We end up with a positive 4, and sure enough, the 3 does go into 9 3 times, and we have ourselves positive 3. And this does equal 7. So when the two numbers do agree again, we say, yes, that point is on the line. So the common mistake I see people make here is sign errors. So make sure you're really careful with the sign. Negative times a negative made the positive. All right, on this next one, we're going to rewrite our 5, but in place of the x, we're putting the value that x is. So x is negative 1. So 5 times negative 1 minus 3. Now think of this as like negative 3 being multiplied by the y value of negative 6. And so once we multiply those, combine them, it should equal 14 if that point is on the line. So we go ahead and do some work here. Negative 1 times by the 5 makes it a negative 5. The two negatives here cancel out and make a positive 18. And we see if it does equal 14. Well, when we do this subtraction, we end up with one number shy of 14. We end up with 13. Since the two numbers are not the same, that means no, the point is not on the line. The next type of question you're going to be given is one about writing an equation in slope-intercept form. So slope-intercept form is this: y equals mx plus b. You want it so you have an intercept, which is actually the y-intercept, the b term, and m represents the slope. Well, before we get it into this form, we need to use the point slope formula. So we're going to use this formula: y minus y1 equals m, the slope, times x minus x1. So we're just going to take our point, the 3 and the 5, and we're going to put it in for y1 and x1. And then we're going to take the slope 1 and put it in for m. So the 1 goes in for m. This 3 goes in for x1. Now you got to be careful. x1 is the last number in our equation here. And the 5 goes in for y1. So that goes all the way over here in the y1 spot. And so we go ahead and rewrite the equation with the y minus 5 equals the slope, which is 1, times x minus 3. So you go ahead and do the distributive property. Well, 1 times the number doesn't change anything, so we end up with those same values. So now we have y minus 5 equals x minus 3. From this point, we're going to add the 5 to all sides. And so when I do that, I have to add the 5 to negative 3. Now watch the signs there. They're opposite, so we subtract those two numbers. So we have y equals x plus 2. That is our equation. We've got another problem to practice here. Slope is negative 1/2, passes through this point. So again, I'll rewrite my point slope formula, and I'll go ahead and substitute my values in for y1, m, and x1. So we'll rewrite this as y minus, and then this time we have a negative 2. So minus negative 2 equals the slope, negative 1/2, multiplied by x minus 4. So 4 was the x1 value. So when I distribute that negative 1/2 over this subtraction here, I end up with this negative 1/2 x and a positive 2, because I'm taking half of 4. 2 goes into 4 2 times. Now watch the signs there. Negative and a negative make a positive. That's the common error people will make, so watch that. Well, over on this side, minus negative makes a plus positive, so change that to plus 2. And then we just have one step to go. We just have to move that 2 over. So you see now it was a plus 2, so we have to take 2 away. And when I do that, I end up canceling out the 2 on the right-hand side, leaving me just with negative 1/2 x on the right side. So that means the y-intercept is 0. Well, let's take a look at our last problem here. Now, in your homework, you'll have a series of points, but you don't need 4 points or 3 points. All you need are 2 points to come up with the equation of the line. So the first thing you're going to end up having to do here is find the slope. So we got another formula to use. So it's the slope formula. It's the difference of the y values, so y minus y1, over the difference of the x values, x minus x1. The little 1 just symbolizes a different point, different value for the y value here. So we go ahead and substitute our numbers in there. It doesn't matter which one you call y and which one you call y1. Just take the two y values, the 1 and the negative 2, and you put those in the equation. So 1 minus negative 2. A common mistake is people just have 1 minus 2, but it's minus negative 2. It's always you're always taking the difference, and here when we take a difference of a negative, you end up actually adding. And we'll see that in the next step. But before we get to that, let's go ahead and write the x values. So I started with this 1 here, so I got to start with the x component of that same point. So 1 minus 2. So I go ahead and do some work here. Add the opposite as I mentioned before, and I end up with a positive 3 over negative 1, which just makes negative 3. So now we have our slope. So now we just take one of the points and we put it into the point slope formula like we had done the last two problems. So it doesn't matter which point you pick. I'll pick this point here, 2, negative 2. So it's y minus negative 2 equals the slope of negative 3 times by x minus 2. And so just took the y value here, and I called that y1. This is my x1 value, and I just substituted into the point slope formula. And so from this point, we can go ahead and rewrite this as y plus 2, because that minus negative made plus positive, and I'll distribute that negative 3 over that subtraction. So I've got negative 3x plus 6. So negative times the negative made a positive. So I go ahead and just do that final step of taking 2 away from all sides, and I end up with my answer. Y equals negative 3x plus 4. There it is. Well, looking at our next problem here, we're sketching the solutions of the linear inequality. So let's start with this equation here, this inequality. We'll start with the y-intercept. This is our y-intercept. And so it's where it crosses the y-axis. So I'm going down 3 spaces on my y-axis and putting a dot. The slope is 2 to 1, so I'm going up 2 spaces over 1 to the right. Up 2 over 1 to the right. And you see, the nice thing about this form is that it gives us lots of points to be able to represent that line. I could also go down to left 1, gets me on that same line. Now before we draw the line, look at the inequality, and it tells us that the values of y have to be greater than, not equal to, but greater than. That means we're going to end up with a dashed line. The dashed line just symbolizes that this is the boundary between solutions and things that are not, points that are not solutions. And so the line does not represent any solutions. So the values of y are greater. Greater means bigger. And so notice this symbol right here is y is greater. Y is greater or bigger. And so bigger means above. Y values that are bigger are above this line. So that's the direction that you'd end up shading. But we can't quite shade yet. We need to graph the next line. Now this is a good one for slope for xy intercepts. So that's what I'm going to do here. Negative 2x is greater than or equal to 6. And I'll set up my other one. negative 3y is greater than or equal to 6. And so when I go ahead and do the work, divide by negative 2, I end up with x is less than or equal to negative 3. Switch the sign because I divided by a negative. Same thing here, y is less than or equal to negative 2. So that gives me 2 points, negative 2 and negative 3 on the x-axis and the y-axis. And it gives me some points to draw the line. Now the line this time is solid because it represents solutions, because it's equal. Notice how it has that line underneath, so that means it's a solid line. Now which way do I shade? Well, either of these will give you the answer. X is less than negative 3. Less than means to the left. Or y is greater than or less than negative 2. So the y values can be less than a negative. So less means below, and less than on the x value means to the left. So you can see either of those will give you the same solution. Either basically means to below and to the left of the line. So the region that you would end up shading would be right in this area here. Well, let's take a look at our last one here. This one's a little bit different because we've got to get either y by itself or solve for the x and y intercepts. Here I'm just going to end up adding this 1 to both sides. So you see, if I add 1 to both sides, I end up with this. Y is less than or equal to. Notice how the inequality sign points to the y. So I'm going to have it point to the y if I bring the y to the other side. See how it's open to the 2x? So it's still open to the 2x. So I haven't changed anything. Just moved that negative 1 to the other side. And so now I can go ahead and graph that a little bit easier. I can start with the positive 1 and use the slope, 2 to 1, to graph it. So it's up 2 over 1 to the right. Up 2 over 1 to the right. I could also go the other way, down 2, 1 to the left. And that gives me some other points to be able to graph. And this is another solid line because you see the line underneath the inequality sign. And which way do I shade? Well, this time y is less. Less means below the line. So I end up shading down below there. Well, let's take a look at our next equation. Here I've got 2x minus 5y less than 10. So this is a good one for xy intercepts. So 2x is less than 10. Negative 5y is less than 10. So you go ahead and solve by dividing here. So x is going to be less than 5. Notice I did not change the sign this time because I divided by a positive. But over here I do. Y is greater than negative 2. So let's go ahead and plot those points. Negative 2 on the y-axis, positive 5 on the x-axis. And then we go ahead and graph that line. Now it's a dashed line because the line, or the inequality sign, does not have that line underneath. Now we've got to figure out the shading. The values of x need to be less than 5. Less means to the left. Those are the smaller x values. You can see the negative x values are to the left, positives are to the right. So that means less means in this direction. So that's the direction I would shade. Or you can look at the y's. Y is greater than negative 2. Greater means above. So all the values of y need to be bigger than negative 2. So here's negative 2, so it goes up in that direction. So which way do we shade? Well, look at the inequalities here. The arrows tell you the direction to shade, and this is the region that they agree in. Well, that's part 1. So on the part 2, you'll see more problems similar to handout 2A.